Mathematical physics. What is energy? We're going to start by talking about system and environment. That helps us work energy principles and problems. We then will try and define energy. Very tough to define that. And then work, which is how we change energy. And then finally, we'll talk about some applicable conservation principles. System and environment. In the rockets unit, we learned to use Newton's laws to explain and predict the motion of objects. We use the second law to find acceleration from force and mass. Then we use the motion equations to determine the velocity or the displacement of an object. In this unit, we will take another approach to explaining and predicting the motion of objects, still our end goal, by calculating something called energy. But before we can talk about energy, we need to set up some ground rules for how we will solve the problems. And we need to define the system and the environment. And then we'll begin to answer what is energy. We learned about forces and solving physics problems in the rockets unit. But have you ever wondered how we can actually solve a problem? After all, every object we study is in some way affected by a whole bunch of other objects. In fact, you could say that any object is affected by everything else in the universe. We know that the moon exerts a gravitational force on the Earth, so it must exert a force on every other object on the Earth. Why then, when we worked out the motion of a drop ball near the surface of the Earth, didn't we take into account the effect of the moon's gravity? Or for that matter, the gravitational force from the sun and all the other planets and ... When we solve for the motion of a drop ball, we only consider the gravitational pull of the Earth because the Earth's gravitational force on the ball is so much bigger than the gravitational force of the moon and everything else, including the sun, that we can ignore everything but the ball and the Earth when solving the problem. However, if we wanted to solve for the motion of the tides, we absolutely would have to take into account the gravitational force by the moon and also the sun. But for just a ball falling from your hand, we don't have to worry about the sun or the moon. Even though every object in the universe can affect every other object in the universe because the force of gravity is theoretically infinite, most of the effects on any one object are too tiny to care about or measure. Often we can just consider one or a small number of objects and ignore everything else. So here's our very simple model of the universe here, and you've got a bunch of different objects moving around in different directions. Here's what we do. To solve problems, we divide the universe into what we want to look at, right here, and then everything else. And everything else are these guys, and everything else that is in the universe. We're just worried about what's in this box here. This little box has a special name. It's the system. The little piece of the universe that we look at when we solve a specific problem is called the system. So when we're solving the problem of the ball dropping from your hand, the system would be the ball, the hand, and the Earth. However, if you wanted to study the tides, your system then would be the water, the Earth, the moon, and the sun. So the system depends on what kind of problem you're solving. Now, a system may consist of one or more objects or an amount of material in a certain region of space, and we put an imaginary boundary, that's what this dashed line is, or a picture frame around the system. Everything else, because we now have to name that part of the universe, is called the environment. That is everything outside the system boundary. Couple more definitions. Systems can be closed or open. When a system is unaffected by anything in the environment, okay, here's the environment, here's our closed system, we call it a closed system. It's as if the system was in a universe by itself. Objects can't leave, no other object can get in, and no outside forces can affect anything inside a closed system. So what's the opposite of a closed system? Open system. And you can see here we have dashed lines which indicate some level of permeability. We will call that an open system. Now, we're focusing on these objects. We want to know what happens to them, but they are affected by the environment. Objects might be able to leave. This guy here could shoot out like this. Other objects could get in. And some outside forces can affect the objects in the systems. Maybe not all of them from the environment, but certainly some of them. The reason we separated the system from the environment is so we can make problems solvable. By defining an appropriate system, like we talked about earlier with the tides or just dropping a ball from your hand, we can isolate the forces that are within the system from the forces that act on the system from the environment. And the whole reason we're doing it is this has energy implications. Forces inside a system will not change the energy. Outside forces that act on the system will change the energy. And we'll talk about that later on.